When we were talking about the force length properties of muscle, we assumed we were making all these measurements with the muscle not moving. So we would stretch it out, hold it still, then take a measurement, which is why we called this peak right here the maximum isometric force, meaning the muscle isn't moving. But what if the muscle is moving? What if the muscle is either eccentrically or concentrically contracting? Well, we had to introduce this idea of a force velocity curve to understand that. So down here on the x-axis, we could put the muscle velocity. And you may see this done in either way in say textbooks or online or other places. I have concentric contractions going off to the right and eccentric contractions going off to the left. So this is the muscle shortening going to the right. This is the muscle lengthening going to the left. And of course, muscles always produce forces that try to shorten the muscle. But if the stretching amount or stretching force on a muscle is bigger than the force the muscle produces, then you have an eccentric contraction. So there is interesting behavior that muscles have when you test their force production capabilities at various velocities. And for this curve, we're going to assume that we make this measurement at the optimal fiber length. So what happens when the velocity is 0 and the length is the optimal fiber length? Well, our force production is just this F max, or I think maybe you called it in the last video F naught, same thing. And then if the muscle is contracting concentrically, maybe the muscle is contracting concentrically very slowly, you get a little bit less force production. And if it's moving faster, so the contractile velocity is bigger, you get less and less and less. So you get this curve that looks like this. And eventually there's a point at which the muscle is moving so fast that it cannot actually produce any active force. This has a special name. It's the maximum contractile velocity, or maximum shortening velocity. And I think we denoted that as V max. We also saw this interesting behavior where if you're doing an eccentric contraction, the muscle can actually produce more force than it can in an isometric contraction. There's this eccentric force amplification that happens in eccentric contractions. And that, I think that ends up being about like 1.2 to 1.8x, whatever the optimal, or whatever the max isometric force is. There was one more piece to the force velocity curve, which was this idea of power. The power a muscle is producing equals the force times the velocity, which we can interpret as being the area, like the area of a box, like this force multiplied by this velocity gives us some area, whatever that area is. So the things to note about this, number one, power, not force production, but power is 0 when the velocity of a muscle is 0. It's not like the muscle isn't doing anything. It's just that you're not actually producing any power. You could think about it as if you were on a cycling ergometer and you were isometrically creating a really large force against the pedals, but they weren't moving anywhere. Obviously, the power output would be 0. And then there's another place where, so if we're thinking about what's the area of like a box like this versus a box like this versus a box like this, there's another area where there's another spot where that area goes to 0, and it's at the maximum shortening velocity. So obviously, if you can't produce any muscle force because your muscle is moving so fast, then you can't have any power output either. So the thing to remember about the power curve is that not the specific shape per se, but just that it goes up and then it goes down, and the maximum power occurs at a velocity of about 30 to 35% of this Vmax. So whatever the absolute fastest your muscle can contract while still producing some tiny fraction of a force, about 30-35% of that speed is the contractile speed that will give you maximum power output from your muscle. Not maximum force production, because remember, that's something different. But the maximum power output, which is how much work can you accomplish per unit time. Or, as this equation has it here, the force you produce multiplied by the velocity that your muscle is moving at. So that's the other important aspect of the force velocity curve.